MCT4C day 28. Today's goal, we're going to be doing some graphing exponential functions, which is review of grade 11 stuff for everybody, but it, you know, it's worth a day of practice for sure. Last year we got to the point where we could graph these functions without a table of values, but this is where we're going to start. We're going to, you know, calculate these graphs using a table of values. One thing I've used, I've put my scale in already here. You don't have to have your scale matching mine. It's not like with the trig functions when we had a very specific scale that we used. I'm going to use just about any and all scales here, so they'll be all mixed up. How do we figure this out? Well, that's the function. X is these values from -2 to 3, and so the idea here, rough value, negative exponent, flip. So that's 1/9. And then this would be 1/3. Anything to the exponent 0 is 1, and then 3 to the exponent 1 is 3. Then I'm multiplying by 3 as I go up, and so on. Some of these we won't fit onto our graph. And so how would I graph that? Well, -2 1/9 is almost on the x-axis, the x-axis there, and then -2 is there. 0, 1 is a point on all basic exponential functions. 1, 3 is a nice point, and in fact those 3 points right there are going to be ones that we're always interested in. When x is -1, 0, and 1, we're always going to want to plot those points on any exponential graph, because a lot of times we're not going to be able to fit the rest on. 2 to the exponent 9 is, up here somewhere. So if I were to estimate, it's going to be, up here somewhere. And then try and do a nice smooth point. You can probably do a better job than me at this. And there's the graph of y equals 3 to the exponent x. We are going to want to get to the point where we can graph these functions without a table using just these 3 points. Here, when we've got a fractional base, well, what's 1/2? I'm going to change my color. 1/2 to the exponent -2. Well, minus exponent means flip the base. 2 over 1 to the exponent 2, that's just 4. 1/2 to the exponent -1, well, that's just going to be 2 over 1 to the exponent 1, which is 2. Anything to the exponent 0 is 1. 1 there. And then I get these fractions. Okay. And so -2 is 4. -1 is 2. That's just the flip of the base, isn't it? And that was the case for the green function here, flip of the base, where the base was 3. -1 gave me the flip of the base. All exponential functions go through that point right there, 0, 1. 1 1/2, 2 1/4, and then we get this function. That's not very good. Should I try again? I don't really care too much. You're going to do a decent job. This is hard for me to do on my tablet. One thing I want to mention is to show the nice big fat dots, okay? That's important because today we're going to be doing transformations for these functions just like we did with the trig functions. And so hopefully we're going to be able to graph these exponential functions using these 3 points without a table of value. It's kind of like we've memorized those ones. Okay, so here we go. And there's the 3 points I was talking about. In general, the graph y equals b to the exponent x has these points. Well, -1 was the flip of the base. The flip of the base. 0, 1 was always on the graph. B to the exponent 0 is going to be 1 no matter what b is. 1, well, b to the exponent 1 is just b. And then those 3 points are going to allow us to graph any exponential function very quickly. The graph is increasing if what happens? Well, if b is bigger than 1, right? If it's a whole number like this or any number bigger than 1, it's going to be going uphill like this, right? Where that point is 0, 1. When x is 1 over here, we get the point 1b. And over here, when it's -1, we get -1 and then the flip of the base, whatever the flip of the base happens to be. However, if I have a decreasing function is exponential decay, increasing function is exponential growth. If what happens? Happened over here, right? This is a decreasing function, exponential decay, we talked about last year. The base is a fraction. If b is a fraction, or maybe a decimal, right? A fraction or decimal. Decimal. Oh, here, you fix that up. And in fancy math terms, what we're talking about, a fraction or a decimal, it means b is somewhere between 0 and 1. We never think of having a negative as the base. And that looks like this. Still goes through the point 0, 1. That's still point 0, 1. And the other points are the same, just that with fractions it kind of looks a bit weird. It has a horizontal asymptote. Asymptote is, where a function gets really close to a line and never crosses it. And it's also one of the funnest words in math to say. Asymptote. 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 But it's the x-axis. X-axis, but usually we label it with the equation of a line. The equation of this horizontal line is y equals 0. The domain, notice what's the shadow on the x-axis here? Shadow on the x-axis, well, there's nothing I can't take the exponent of. It's all real numbers. But the range here, well, the range, what's the shadow on the y-axis? The shadow on the y-axis for both a growth or decay function, notice that since it has an asymptote, it's never ever going to touch y equals 0, and it's never going to be negative. So the shadow is just these numbers. Well, how would I describe those numbers? Y has to be greater than 0. And that makes sense, because when I put numbers into here, I always get positive numbers. Okay? And now what are we up to? Well, and again, I've got my grid already written in there. We're going to do some transformations of functions. The basic graph, I'm going to draw the basic graph. Remember, it has points. All of them have 0, 1, 1, 5, right? Because it's the base is here, and x is 1, the output's 5. And then -1, the flip of the base, right? -1, the flip of the base is 1/5, and then I can write those numbers really quick. There's 0, 1, 1, 5, and -1 is a fifth, and I just got to estimate that. And I know that this is a exponential growth function, so it's going uphill. It's increasing function, and there it goes. Notice at x equals 2, 5 to the exponent 2 is 25. It'd be way up, way up, way up. Right? Way up at the top of the screen. This is the basic function now. For the rest, I'm going to have transformations to these. Okay, so for this one, notice there's a minus. Well, what does that minus do? Well, it's out front. It's not in with the x, so it's going to be a reflection. We remember that from trig functions and from all the functions we did last year. This is going to be a reflection. A flip is what I like to call it. A flip, but in the direction of y. If it was in with the x, it would be in the direction of x. But this is going to flip down here this way. Flip in direction of x, or of y rather, which is over the x-axis. Over x-axis. It's going to flip down this way. Right, so all these nice points, these big fat points that we drew, get flipped over the x-axis, so it's a reflection in the direction of y. 5 units right there. And now notice that our increasing function is now always decreasing. So that's something that we're interested in, is increasing and decreasing functions. Lastly, we've got a minus in with the x. So this is going to be a flip or a reflection in the direction of x. So this is the x-axis. It's going to flip this way. These points are going to flip this way. So it's going to, be a downhill function this way. Flip in the direction of x, notice, and that's over the y-axis. And I know some people get this mixed up, but if you think of, what direction things are affecting in here, then hopefully you'll keep that straight. This minus is in the direction of x, so it's a flip in the direction of x. It's a horizontal flip. And so these nice important points get flipped over the y-axis. That one gets flipped to there. This one stays on the y-axis. This important point gets flipped to there. That one there gets flipped to there, and then I see that is y equals 5 to the exponent minus x. And you might be thinking, hang on a second here, what's going on? I thought you said that this looks like a decay graph. A decay graph has a fractional exponent, or a fractional base rather. What's going on here? Well, one way to think of this 5 to the exponent minus x, is I could simplify this using my exponent rules. This is the same thing as this, isn't it? Think about multiplying the exponents. Negative 1 times x is minus x. Well, 5 to the exponent minus 1 is 1/5. This is the same graph as 1/5 to the exponent x, and it is indeed a exponential decay function. Okay, I'm going to stop there for part 1. We'll pick up part 2 momentarily.